Okay, so yeah, I posted a link for the Google Colab that we're going to be using in the general chat. So if you guys can go there and try to open it, see if it opens okay. Yeah, the name is tut8_batch_exercises when you open it up. So make sure you save a copy of it if you want to try to practice with some of the exercises later on. And yeah. I don't hear anything. Are you guys being able to open the file? Should we start?
Yeah, for me.
Yeah, all good.
Okay, so yeah, the idea that I want to show to you guys today, it's mostly we've been seeing how the batch simulations work, how we can change the parameters within NetPyNE to actually play with the values in our simulation. So what I kind of wanted to show here is like how you're going to be interacting with the batch file. So if you guys want to go to the left and just open the folder here, you're going to see that you have tut8_batch_exercises, and then there's a file structure there. Can you guys see it?
Yes, I can see it.
Okay, so as we said before, there's 4 files that we have to work with when we're running batch simulation. So it's the batch file, the config file, the init file, and then the netparams file. So the init file is gonna be calling the config file and the netparams. The netparams where we have the more permanent setup of the network, and the config file is the ones that we're gonna be changing throughout the sessions. And then the batch file comes on top and changes everybody else. So because of the limitations that we have in the Google Colab, and we were just like last night trying to like figure out how to make it work, I made separate config files and netparams files for the simulations that we're going to be doing, mainly because of the thing that we were telling in the previous session with Joe, that sometimes when you want to change something in the netparams, you have to go and make a change in the config file, and then change. I'll add that change into the batch file, so you can go down the path and then actually change what you want to play with in the netparams. So I couldn't make it run in the batch file itself only, so I made the separate files. So what we're gonna be seeing here is just how you can like go and play with those values. So you want to go ahead and just look at this exclamation pwd just to show the location that we are. So because I was running before, I was in a different one, so we're going to change the content and then run pwd and execute the installation of the software. So new NetPyNE, matplotlib, blah, blah, blah. So I already have those installed, but I'll give you guys a little bit of time to get those if you don't have them. We have this like line here.
Hold on one sec, Joao. It seems like there's some questions in the chat here. Do you guys see the batch exercises and the folder?
No, I don't. I can only see sample_data.
Oh, okay. So yeah, sorry. Maybe if you run the steps and get to git clone. Yeah, my bad.
Okay, I'm sorry. Yeah, I'm sorry. I made the same mistake earlier.
Yeah, I'm sorry. Yeah, so just go ahead and run until step 6. You should get a copy of the Git directory. So basically, we're installing everything, and then I'm just checking the path to remove those. This is more of a security step if you guys want to run this later on. And so we clone the repository, and we should have everything here in the folder 3. Yeah, it's updated mine. So yeah, I'm sorry. So we're going to see the batch, config, init, and netparams. But we're not going to use this netparams here and this config here. We're going to use separate ones for each simulation because of the limitations in the Google Colab. But usually you just need those 4. So we clone the repo, and so checking the place where I am, and we're going to change into the folder that we just cloned. So if you do ls the current folder, which is content. We're gonna see.
Hi, Joy. Question.
Yes.
I am also not able to see the tut8_batch exercise folder. I'm seeing a lot of folders over here: bin, boot, contents, but not the one which you are showing in your collab.
So I don't know.
You are up a folder too high. You need to go into content, I think it is.
Yeah, you have to be in content, and then you're gonna have the sample data, and then the tut8, and then you can open the.
So
yeah, it's in content.
The PWD shows content.
Mm-hmm. Okay. Yeah.
But then, like, I'm not seeing the folder which you are showing here.
So because like the visualization that you have like with the folder tree in the left, it has nothing to do with the folder that are running in the collab. So you might be in the right place, but you're just not seeing the right files on the left. Yeah.
Okay.
Okay, but yeah, just trust me, it's gonna be like those here in the hierarchy. But if you execute the steps, it should be with everybody else. So if you git clone, you will have that, and we're just gonna change into this folder that we created, tut8 batch exercises, and yes, we should be everybody in the same page. If you put here an exclamation LS, you don't have to do this, but it's just to show that we are in here. So we have the files tut8 batch, the init, netparams, and the config, and then the separate ones that I made for this specific session in the collab. But we don't have to bother about this one. So these are like some debugging sections that I made, but you can skip those and go straight into the running batch simulation. So my idea for you guys today is just so we go through it and I show you guys how I do one of the batch simulations, and then we create one together, and then we can go back and forth and try to set up another one. So the first one I want to show is the Iclam simulation. So for these ones, we specify the params that we want to change. In this case, it's going to be the clamp amplitude that we're going to provide to our model cell. And all of the configurations that we need, they're specified in the config iclamp and tut8 netparams iclamp. And I'm just going to give it a run and show you guys the result. And then we go back and try to understand what's under the hood. And just one thing that we want to check, yes, is that I have the function change iclamp being called.
Sorry, can I ask if you can increase a little bit the font size?
Yes.
Thanks.
Yeah, that a little bit better. Yeah. So let's give it a run. You should look here in the prompt. You should see that it's running the batch simulation, and we're changing over a span of parameters that we chose from.
Hold on one sec, Joao. I wanted to change something before I ran it?
No, this first one we just want to execute.
Okay, great.
I let the parameter set up. Yeah, you just want to make sure you're running the change iclamp in the bottom.
Okay, yeah, so that's commented out by default. I need to uncomment that?
Yeah, that was my bad. When I moved into this notebook, I forgot to like change this one.
Yeah, no worries. I was just making sure.
Yeah, so just change this one to change iclamp, and then when you run it, you should see the prompt. So let's go break down a little bit into this one. Might be a bit helpful just to understand what's going on. So we're going to have all for each parameter that was set up. So we had 0.05, 0.1, 0.2, 0.4, and 0.6. So these are the amplitudes of the current that we're providing into the cell. And we don't run parallel jobs here. So you're only going to see job rank ID 1, and then they go one by one, blah, blah, blah. And you're going to execute, gather the data, save it, go for the next one. And then at the end, you finish it. So if we go and run ls, remember, we're still in the same folder where we have all of our scripts, but then we have a new one here. It's called tut8 data iclamp. So we're going to go ahead and change into that folder. And we're going to run another ls just for demonstration. And then we see that we have a bunch of files that were inside this folder. So we have the config file for that specific parameter that we set, the JSON, which saves the data, and then the traces, which show the plot. You can see that we only have one net param, so it's kind of helpful to keep the idea in the head that the net params, we don't play with it that much. We just change the config file. So that's what the batch does. And in the next code line, we're going to look for the files that end with traces.jpg, and then we're going to open them just so we see the output of our simulation. I wanted to show you guys like an analysis and stuff like that, but it just became like too much to cover. So we're just going to go and look for the shape of the plots that we're seeing here. So we see that for the first one, 0.005, it's a very small weight it's a very small current into the cell, so we just have like a little step, and then we keep increasing it. It increases a little bit more, and then boom, we start getting an action potential in the cell. That was changing the clamp amplitude over a range of parameters. So hope you guys also got this one. Did anyone have a problem or got stuck? Okay, very good. So you can go ahead and close this window just so it doesn't get too messy. And now the next thing that we want to do is to build one ourselves. So instead of using the configurations that we have for the Iclam, we're going to do a different simulation, which is to provide a cascade of net steam. So we've talked about this before. It's something that we have in Neuron and also in NetPyNE, that we just provide artificial EPSPs into a location of the cell. So here we have our params section. And then here is the place where we're going to tell which parameter we're going to be playing with. But we have to know which ones we can actually access in first hand. So we're going to go ahead and look into those files on the left. And then we're going to look specifically for the one that has tut8 config net steam. We're going to go ahead, double click that one. So we open that on the right. And also the net params. So it's going to be the last one, tut8 net params net steam. So, okay. And I'm going to go and just increase the size here. And I'm going to show you guys how we actually have this net steam. So this is the network setup, is the same as for the Iclam. So we have our cell that we're simulating. We have the population parameters. We have like 2 populations in this simulation specifically, synaptic parameters. But then in the bottom here, we specify this net steam inputs. I'm going to provide you guys with the files later on that we can have like all of this net steam, the Iclam, and all of those functions. But just bear with me for this one. And the parameters that we can provide for this net steam are the population that we want to stimulate, which section of the neuron, the location, the synaptic mechanism, the weight factor of the mechanism. This is for when you have more than one synaptic mechanism. So for example, GABA A and GABA B together, they have 2 different time dynamics, or AMPA and MDA. So we just put a ratio between the 2 of them. You can also say when the stimulus is going to start, the interval between the stimulus, the noise, that's going to be like how much shift you have within the time that you provide those stimulus, and a number of stimulus, the weight of each one, and then the delay for that. So those are all the options that we have. But as we were saying, we have to get those parameters and export those into the config file so we can play with them and then access those in the batch. So if you look down here, usually start here, I would just have start in this variable. But the way that we can do this is to go and type config start steam time if start steam time is not known, else start. So if we don't have this variable set, we're going to look for the default one, which is start. I was going to do this interactively with you guys, but I tried to do this on the collab. It crashed. So I just have them set up. Yes, I'm sorry. So I already have them set up for you guys here. And then we're just going to go and look how those are declared in the config file. So we have start steam time. We have the intersteam interval. This is a variable for that. We have the number of steams, and we also can change the weight of that simulation. Sorry, the weight of the steams that we provide for the cell. Make it more clear. And those are the values in the config file. So if you look at simple configuration, we should have something like this, and then we added those other variables that we can play with. So config synmac-tau2, this is something to play with the synaptic mechanisms. Con weight, we're also not changing this one, but the ones in the next steam that we just exported. So we give them a default value, so config.numSteams, config.netWeight, start steam time, steam interval, and then we just pass them into this dictionary here. So all of those parameters that we saw there in the netparams file, we have them here, and then we're calling those. We're setting the config add netsteam as true, and if you recall from the netparams, it's a condition that we have in there. So if it is true, they're gonna set it up, and we can access this type of stimulation in the batch and play with those parameters. So I'm gonna just put them here to the side, so we focus now on the batch simulation, and we want to go ahead and add a new parameter that we're going to play with. So I tested those before. I'm going to go into my cheat sheet just to make sure we run something that's going to give a good result. And I want to change the weight of the stimulation that I provide here. Does any of you guys want to give it a try? Maybe have a suggestion of which parameter should I be passing here? Let's make it easier and show you guys the Iclam on the top. Yeah.
Is it config.netWeight?
Yes, that's 90% correct, but yes, we only say the net weight, but yeah, perfectly. That's the parameter we want to, yeah. And so net weight, and okay, we have them here. And then we want to give a span of values that we want to search through. So I'm just going to go and like type some parameters that I already looked into just to give an overview of how they look like. So let's go through 0.0005, 0010, and 0025, and let's see what we get through that. So we can try to go and run the batch here, but we have to do a few things first. And the one that's important is to change the function that we're calling. So we're having those steps being set up within functions. So we just uncomment the change netsteams, and we comment out the change Iclam. So we have that one.
One sec, Joe. I'm trying to keep up. So you moved way up and changed those in the early one?
Sorry, which ones?
Yeah, what did you just change now and where?
Oh, sorry. Yeah. So I'm gonna show again. So you can leave the Iclam as it is, and we're just gonna go and scroll to the bottom to the following function, which is the change netsteams, and then we want to change. And then we want to add params net weight, and then this weights here. I'm gonna post those in the chat just to make sure you guys all have the same thing. So we just want to add that line. We had an empty structure, and we want to paste that one there in the change netsteams function. And then the next step that we want to do is to scroll all the way to the bottom, where we have like the main code being executed, and we're going to comment out the change Iclam, and we're going to uncomment the change netsteams. And okay, we can go ahead and save this. I was having a little bit of trouble when you try to rerun.
One sec, Joe. I'm not quite caught up yet. What did you change on the bottom there?
So you just comment out the change Iclam. Yeah, okay. And then you leave the change netsteams uncommented.
And uncomment change netsteams. Okay.
Yes.
And then change cell parameters. I want that commented. Okay.
Yeah.
So everything except change netsteams. Okay.
Yes. So the thing is, if you try to rerun this, it's throwing back an error. I don't know if it's like carrying some trash from the previous simulation. So what you can do is just go ahead, scroll all the way to the top, and then we re-execute those steps. So you go into the runtime, restart runtime. Yeah, not the most convenient thing to do, but yes, at least it gives you a clean rerun through the parameters. And then you just can go and shift enter through those first cells. It's just going to recheck everything because you already have those installed. It's going to remove the batch oops, I'm sorry, Phil. Okay, my connection dropped a little bit. Okay, so yeah, you're gonna go reclone the repo. I hope everybody followed to this point, and then yeah, you can just check it, and you're gonna change into the folder where we cloned the repo, and then you can scroll back into the batch. All the modifications that we did, they're still preserved here, so we can just go ahead and rerun it. And if you look here in the bottom, it should have changed the parameters. So previously we had the Iclam, now we have the net weight being changed, and we're going through 0005, 001, and 0025. We only have 3 parameters to go through, so those should be fairly quick. Can collapse this Iclam data, and then yeah, we have another section here where I made so we can look into the NetSteams simulation. So we just created this data folder with the data from the NetSteams. So we're gonna cd into that so we can access the files, and we're gonna run this code block so we can visualize the figures that we got. So
I have a rather silly query. We changed net weight in this run, but we can also equally alter number of stems, start stem time, interstem interval. These parameters can also be added, right?
yes, perfectly. Yeah, that's one of the things that I want to propose you guys for the following ones. But yeah, those are all accessible. I let them accessible. You can play with those as well. We'll see how the time flows here in the exercise, and then we can play with those as well. But yeah, because you can pretty much vary all of those parameters there.
That's what I wanted to know. Okay, thanks.
Okay. Yeah. So if you see here, the NetSteam underscore 0 traces. As we progress, you can see that the peaks, they become higher, but that's because we're increasing the weight of the stimulus that we're providing. So they become cancel. Okay, whatever. So you can see that you can play with those weights and then keep increasing those as you need. And yeah, we might want to go ahead and play with another parameter. So does any of you guys want to suggest one parameter that you want to look through? We can play with the net weight, the start steam time, the intersteam interval. Okay, let's do the intersteam interval. So now what I'm gonna do, actually, instead of just running and playing with the intersteam interval, I'm gonna show two things that at the same time. First is playing with a different parameter. So you want to go ahead and type below the net weight, you want to type params, brackets, single quote, then you paste it in there. Intersteam interval, which is the next variable that you want to look for. And then within the brackets, you put the range of values that you want to iterate through. So I'm gonna go ahead and just like add some values here. And so instead of having 15 milliseconds of interstim interval, we're gonna have 5, 2.5, 1, 0.5, and 0.1. But the difference when you're running these two parameters together is that we're gonna explore a combination of each of them. So the first thing is that we're gonna fix one parameter, so 0.05, and then we're gonna change all the other ones. So interstim interval is gonna go 5, 2.5, 1, 0.5, 0.1. And then NetPyNE is gonna change to 0.010, and then reiterate over this list, and then 0, 0.25, and then iterate over those. And it's always, usually the first one that you declare first is the one that's changed less. So we can go and we can go and to the top and start a new clean version. So restart the runtime and execute again, just to prevent any errors. So Shift Enter through the first cells.
For me, it seemed like you could not rerun, but just make the steps from the debugging sections that clean the folders, and everything works okay. At least it was the last time.
Yes, I was able to manage that too. I added that debug section just to like remove that. But if you're going from one type of simulation to the other, it was crashing for me. So I just kind of was like,
okay. I don't know. We switched and it worked, but maybe.
Yeah. I was like, yeah, let's like have the two methods, so at least we have like options. So you run everything all the way until before the debugging sections, and then you can skip back to the batch. And yeah, we're already in the change net steams function, so we're adding something into that one. So re-execute that section. Comes the outputs, and now you see a difference. So we have the 0th parameter, which was 0.05, being kept the same value, and we're changing the interstim interval, which is the one, like the first parameter that we have following that order. So we're iterating over all the values of the interstim interval, and then we change again the weight. So you can see all of these combinations here. It's going to take a little bit longer for the simulation to run, but yeah. To 0. Okay. Okay, looks like we're done here. Give a few more seconds. All right, so we can scroll down to NetSteam's data again, change inside the data folder that we just got from the NetSteam's batch simulation. And then we're gonna look through the voltage traces that we got for this simulation. Now we should have significantly more files, so let's see how it look like. So first we have the first combination, so 0, 0. So those are the smallest parameters that we have. So we have a longer interstim interval, which is like 5 milliseconds, and the 0.0005 net weight. So it's very spread out across time. And then we start to reduce the interstim interval, and then we start to see an increase in the, at least in the peaks that we have in the cell, even though the amplitude is the same. So just keep moving. Yes. So this is the last one. We end up with action potential. With the smallest of the stimulus weight, we were able to trigger one. So let's see with the other one. So 1, 0, we changed a little bit, and we can see we have a bigger peaks now. We start to decrease the interval. Action potentials. Okay. For the next value of weight, you can see that we already have action potential, so we start having multiple. Up with less action potentials than you had before, but that's because you start giving those stimulus so close to one another that you end up overlapping the stimulus, and then the cell membrane doesn't have time to react to all those stimulus. So what you end up with, it's actually just a big summation of potential here that's forcing the cell towards the depolarization, but it doesn't actually depolarize. And yeah, you can end up here with the action potential followed by a huge EPSP in the cell, but that's not able to trigger an action potential. So you also have to have this little bit of time within the stimulus to actually trigger an optimal response in that cell. But this is a very dummy cell model. We don't have that many mechanisms that can counteract that effect, so we end up seeing this funny dynamics. Okay, hope you guys followed through all the way to this point. And now we have another exercise, and we change first the two types of stimulation in the cell. So now what I want to do is to change something different. I want to change a parameter in the cell model that we have. So by default, I set up in the file a stimulation in that cell. So we already have a stimulation that's going to be the same. And what we want to do is to change the properties of the cell itself and see how the cell reacts to that stimulation. So what we first should do is to look for the files with the cell params simulation. So we can first close this one with the NetSteam. So we're gonna go here and look for the tut8 config file _ cell params and the netparams _ cell params. If we stretch this out a little bit, we're going to see that they're basically very similar to the other ones, just we don't need to declare all those other functions. We only have an Iclam in the cell here at the bottom. That's the stimulus that we're going to be providing to the cell. And here is where, as we've seen in previous tutorials on NetPyNE, is how we declare this cell that we're going to be playing with. So we have a section of soma, we add the geometry, we add also mechanisms into that cell, and we're going to be saying that this is of a pyramidal type. And so you usually would have numbers here. I went on and already added the config file variables because, as I said, we could not make it run changing those directly in the Colab. So I went on and already added this. So we can play with the diameter of the cell and the length, which I just added as dimension. We can play with the resistance of the cell. And we can also play with the GNA bar and GK bar, which are the maximum conductances of the sodium and the potassium channels that we have. We can play with this GL. I believe this should be the capacitance of the leak channels. And this is the EL, which is the voltage of the leak channels. So those are some of the mechanisms that we have within this cell. And all the values that we had previously here declared in the netparams file, now we have them explicitly declared in the config file. So if we scroll down here all the way to the bottom, we're going to have all of those. So we have dimension, RA, GNA bar, GK bar, GL, and E leak. And those are the values that were in the netparams. I just moved them over to the config file. Yeah, we're also adding an Iclam. That's going to be our control stimulus that we're going to provide to the cell. So with that in mind.
Wait, quick question. The initial values that you give the parameters you're going to change, they don't matter. Is that correct?
Like the ones here that have like dimension, array.
Yeah. Yeah.
Those no, those are actually, they are important because those will be like the default values that you have in our model. For the batch simulation,
okay, so
the importance of that is, for example, let's say I give a dimension of 0 here in the config. And then I go to the batch file, and then I put dimension 1, 2, 3, whatever. When I play those, okay, I'm going to run the batch simulation just fine for if I'm playing with a dimension in the batch. But if I forgot to change this value back, and then I still have a 0 dimension here, and then now I remove dimension from the batch file, and then I add RA instead, when I iterate RA, we're going to be still sourcing through that 0 value in the config file. So yeah, usually you want to have a baseline of that. And yeah.
Okay, gotcha. All right, thanks.
Okay, so the first exercise I want to propose for you guys, now you guys help me build this, is to change the channel properties that affect the resting membrane potential of the cell. So which of those you guys think would be more relevant to actually change the overall RMP of the cell?
The leak channels.
That's a good call. Let's try that out. So the variable that we want to pass to the batch file is going to be the e-leak. So can you guys tell me how that's going to be like?
I believe you just said a e-leak.
Yes.
Inside.
Yes, in the params.
And choose values.
Yes, so let's go for like -90, -80, like 10 and 10, just so that could be something very visible for us. -60. And before, we had to declare the values of the Iclam. So yeah, that's a good complement into, I think it was Jessica's question. So now we already have an Iclam declared here with default values. We're not going to play with those. So we're going to see how our cell not only changes the RMP, but also reacts to that Iclam that we're going to provide to the cell. So, yes, override. Okay. Scroll to the bottom and change the function that we're going to call. So instead of change net stims, change cell parameters. Go ahead and save that, and can go all the way to the top and just rerun those first sections so we can clean the runtime. So runtime, we start runtime, then we execute. pwd content, pwd hit install, remove the previous folder and clone again. Yeah, make sure we clone the folder and change into that directory. Skip the debug, and now we're ready to run the batch. So just give a check on everything. So e-leak, change cell parameters, so we're good to go. Yeah, so we're now changing the e-leak. Okay, so that worked. Now we have another section here that I separated called cell params data, just so we change into the data folder with that, with the data from this simulation. So we want to go ahead and change into that directory and then we're going to go and execute this box. So yeah, let's just show like these two first voltage traces. What difference can you guys notice here? Do you guys see any change in the cell?
In the rest?
Yes, the VREST changed. So because our cell model, this is something that's good to keep in mind. We don't have that many variables within our model. If you look here in the net params, just go here real quick, so that makes sense. We don't set that many stuff in our cell. We only have the HH mechanisms, which are the GNA bar, GK bar, the capacitance, and the leak. When we play with the leak of the HH mechanism, that's going to have a huge contribution. So it's basically a one-to-one relationship. We set that to 90, the RMP goes to minus 90, sorry. We set to minus 90, go to minus 90. When you have a more complex model that you have more channels, changing just the one variable in one channel, it's not going to be that straightforward, but yeah, in this case, it is. Minus 80, we drop straight to minus 80. Minus 70, we go straight to minus 70. But then we start to see something curious, because the step of current that we're providing to the cell, it's starting to provoke a response. And then when we get all the way to minus 60, the amplitude of that current step, it's actually enough to trigger an action potential. So that's something that's pretty common to see. So for example, I'm playing with the model nowadays, not playing, studying a model that it has different behaviors depending on the resting membrane potential. So if you give it a positive current when it's in a very negative resting membrane potential, it's going to trigger a burst. But if it's very depolarized, it's going to trigger tonic firing. So those are variables that are interesting to see, and this is a way that you can probe the cell and test how it reacts differently. Okay, yeah, hope you guys follow through, and let's try to play with another parameter. So let's try to change the maximum conductance of the sodium and the potassium channels. So yeah, let's keep it here, and just so you guys can have a hint of what we should input there. Yeah, maybe let's comment this out. And what should we put here if you want to export those two parameters?
GNA bar, GK bar.
Sounds good, yeah. So params, bracket, single quote equals to a bracket. Yeah, let's make a copy of those. So, and then we pass the two parameters that we want to look into. So I always avoid typing, because typos make your life harder to debug. So yeah, just copy those two, and then we're gonna pass a range of different parameters into that cell and see what that does. I have a few that I tested, so yeah, I'm gonna go ahead and cheat those into that. You guys are free to put whichever parameters you want within a reasonable range. But yeah, I'm going to explore that. I'm gonna put, so these two first are the original ones that we have in the model, 0.12 and 0.036. And then we have two others, way bigger, 0.5, 1.0, 0.2, 0.5. Yeah, let's see what that does. Once again, we are calling the right function. So let's just save this and start the runtime just so we get a fresh and clean installation. Okay. Git clone or S, change into the folder. We're good to go. So let's go ahead and run the batch. Yeah, so first we're gonna iterate through the GK bar. And as we do so, we iterate over the GNA bar. I'll give a little bit of time so everybody catches up. But yeah, what we want to do now is to scroll to the cell params section and then change into the folder with the data files. And let's re-execute the code block to show our figures. And go to the top first, no spoilers. All right. So yeah, let's see what we have here. So these are the default parameters that we have for the channel. Resting membrane potential around -70, and for those two conductances and that current step that we're giving, it's pretty much like the third figure that we had in the previous simulation, where we changed the RMP, which was -70 for that option. And now we're going to change just the GK, so we're having more potassium conductance in the cell. That's just going to make our cell less depolarizable, let's say, because you see that the step in the current clamp, it's actually reduced in amplitude, and yet even less depolarizable. I don't see a very big change in the resting membrane potential, but yeah, that could be something appearing too. And now we ran through the three GK bar parameters. Now we're stepping up the GNA before iterating through the GK bar. So now we increase the sodium conductance a little bit from 0.12 to 0.5. I think so, yeah. Yeah, so we went from 0.12 to 0.5. So we have a huge sodium conductance now, almost 5 times bigger, and we still have the default potassium conductance. So when sodium rushes into the cell, depolarization, action potentials. So you can see that with a little bit of stimulation from the current clamp, now we get a spike. And then the potassium conductance is normal, but then yeah, the cell still a little bit depolarized from the current clamp, and then after the current clamp is gone, we return to the resting membrane potential. But now let's increase a little bit more the potassium conductance. So you see that it balanced out now. It's kind of like a tug of war. So you increase one variable that's going to make the cell more depolarizable, and when you increase the one that's going to make the cell more depolarizable, then you have a balance between the two of them. It's a less stable balance, but yes, it's still a balance. And yeah, the same thing when you increase the potassium conductance even more. And now, for the last value of the increase in the sodium conductance, you see that the cell is just constantly spiking. So it's kind of like you make the cell very much more depolarizable, and when you depolarize, the potassium tries to fight back, but in this 2, 0, the combination is 1.0 for the sodium, 0.036 for the potassium. So it's not able to stop the spiking. So the cell gets in constant spiking regime. If you increase a little bit the potassium, okay, we only get one action potential now, and increase a little bit more, we're back into the less stable equilibrium, but yeah, an equilibrium between the two variables. So yeah, this is just showing how you can play with the channel variables as well. And as we said, because of the model degeneracy, I guess that's the word that we were talking in the previous sessions, different cells in different species, they're going to have different dynamic stabilities, and those are something that you want to account for sometimes when you migrate model from one species to another or something like that. Yeah. Okay. Yeah. We have another exercise in the cell param. So yeah, we kind of like looked into those as well. So you guys got a hold of it pretty well. I was asking here which other properties of the cell we could change. So because we exported those parameters from the NetParams file, we can play with the dimensions, the array, GNA bar, GK bar, GL, and ELEAK. And we might want to go ahead and move into the final example. You guys help me build this one.
I had a question. So
yes,
this, you can also, in the change network parameters, cell parameter, sorry, we can also change start stim time, clamp amplitude, stim duration. Those things can also be iterated through, right? Because they're in the config file for cell params.
Yes, perfect. Yes.
Okay.
Exactly. You can play with those. So yeah, these are the things because yeah, you have those instantiated from the NetParams file. So you exported those, then you can play with those. And I'm gonna show something that's very interesting because in these ones you see that you can just like declare the parameter here and then show it. It's a little bit different when you're playing with a conditional that you change in the config file. Because in this case here, you have to declare a variable and then you have to declare it differently. So it's just so you guys are familiar with this when you're running through NetPyNE code and then you maybe like, what I don't understand it. Why don't I just add the config variable that I need? But yeah, in this case, when you're like, you have one config nested into another one, you might want to use this sentence here. So config.stim duration, for example, which is the one that you're exporting, if the config.stim duration is not known. Otherwise, it's going to look for a default value for duration. It's a bit less straightforward than what we did to change the parameters in the cell, which is just setting the config here, but that's kind of the way it is that we need to set up so we can export into the config file. So that's an error that I ran across multiple times when I started to work with these files until I kind of started to understand a little bit better. So just for the record. But yes, and yeah, we can move to the last one, which is we change parameters in our cells, but we can also change parameters in our network. So let's go ahead, close these files here, and then open the config files and config file and NetParams file for changing network parameters. So let's go to config netpar and NetParams netpar. So just take a quick look on those. So yeah, you see here, I'm not using those parameters for the cell. So they're basically just the numbers defined. I'm not exporting those. But now I want to export other stuff. And where it is? Yes, here. So remember, we use what we had to set up a network was to declare the cell parameters, and then we create the cell populations that will use the parameters of the cells that we declared. And then you can declare the synaptic mechanisms, and that's the building blocks you need to create your connectivity parameters. So here I'm also exporting those connectivity parameters so we can play with the connectivity of this network. So we have the probability. I'm going to call config.conprob. Wait, config.conwait, condelay, synmac. So we can play with the probability, wait, delay, and the synaptic mechanism we provide from one population to another. And those used to be values. So when we add the variables here, we move the values into the config file. So we have them declared here: the conwait, conprob, condelay, and synmac. And now we can go ahead and play with those in the batch file. So I don't know if I actually propose exercise for this one. Yes. So yeah, so can you guys, one of you tell me what would be the sentence I would declare here if I want to change the connection probability?
Conprob.
Yes.
Is it conprob?
Perfect, yes. Okay, conprob.
With one N.
Yes, see, that's why I don't like type. Let me just make sure I exported the right variable, because yes, okay, yeah. avoid typing. And yeah, I'll just suggest a few values, because we can have, for example, 0.1, which is going to be 10% chance of connectivity, 0.25, 0.5, 1.0, and yeah, let's see what that does to our cell. Change cell parameters, we comment that out, and we move out the change network parameters. And okay, I think that's good. And then we want to go ahead and restart the runtime just to get a clean run. Oops. Right, and I'm going to go ahead and execute the batch. Yeah, we're changing the com prob, so we're doing it right. Yeah, you guys can go ahead later on and take a look at the prompt that we get from each of these simulations here in the batch. It's not something to do on a Friday night, but yeah, it might be interesting later on just to like understand how we're setting up things step by step. And yeah, we finished the simulation. Now we go all the way down here.
Sorry, what were the values you used?
Oh, sorry. Yeah,
For,
I might have went way too fast.
I'm a little...
Yeah.
Okay. Yeah.
I just added 10%, 25%, 50, and 100%. So yeah, 0.1, 0.25, 0.5, 1.0.
Got it. Thank you.
And yeah, clean the runtime, re-execute, and then now changing into the folder with the data. And yes, so just one thing I didn't mention here, setting up the net params in the config file. We don't have to always just plot the traces. We can plot other types of data. So we've covered this already. So in this case, instead of showing the traces, which are not that interesting for us, in the case of changing the network, let's just go ahead and plot the raster and the 2D net. The raster is going to be just the dots for each spike, and the 2D net is the position of the cells in the network and their connections with one another. For this, we have two code blocks, and now because I'm looking for first a list with the names of 2D net files, and then I'm looking for the ones that end up with raster_gid, or in some cases they would show up as raster.png instead of raster_gid and .png. And just for the record, this code blocks that I use for plotting here and showing the files, those are exclusive to Colab. When you move into the command line, you're not going to need that. You can access the file directly in the folders that you save them. So yeah. First, let's start looking at the 2D network plots. So yes, we changed from, yeah, they might be small, let's say 500. Yes, so for the first parameters, we had like 10% probability of connection. So we see that there's even cells that didn't get any connections with them. And when we increase a little bit, 25, 50%, which was the default, and then you have 1.0. So all the cells connect to one another. And now I want to go ahead and look into the raster plots. Okay, you might want to increase that in your local machine as well. Just change the width and height to 500, should be fine. And yeah, now what you can see here is that as you increase the probability of connections, those cells are starting to spike even more. Like the cells in the post-synaptic population, which are the M, you're starting to, more of the cells are starting to spike. So yeah, you can kind of see here in the raster plot as you increase the probability of connection. And here in this case, you have all of them spiking all the times. And they're just following the inputs from the presynaptic population, which is the S pop. That kind of concludes this part showing here. There's one thing that I want to also comment about this, is that you can see that only a few of the presynaptic cells are spiking, and this is because instead of using the regular NetStim, I have another one that I like to use, which is targeted NetStim. It's basically the same idea of the NetStim, but I pass a list of cells that I want the stim to go to. You can either specify this by creating subpopulations, like here we have the pop S, but you can also use these ones where you can just go and tell the ID of that cell in that population. So it's not the global ID of the cells, which you only have one ID for each cell. You have, in this case, a different number for a different cell within a population. So the cell 0 from the population S, the 2, 5, 10, and 15. And if you kind of look here, is this 0, 2, 5, 10, and 15, which are spiking. And yeah, and that's declared also, like the code behind this stim is declared here in the netparams.py. Those are all together in the config, the tut8.config, sorry, in the score config.py and the tut8 netparams.py. You can go through those and source those if you want to use those for your project. And yeah. We can also change other things like the connection delay. For example, it's another parameter that we can change, and that's a really interesting one.
So one question, I'm not sure if I missed it. Can you change two parameters together?
Yes.
And the second question.
Yes.
If you change two parameters together, can you make a contour plot?
Sorry, make what plot?
Contour plot.
Contour,
like I don't know if I'm speaking right. So there's a plot wherein
I get it.
I don't think we have a contour plot, but you can make it yourself.
Yeah. Yeah, I was gonna say, because like we saved the files. I was planning to use. We have the class that I think Joe's working on to like show the plots and whatnot. When I started working with this, I wasn't very skilled with how things work, so I kind of made one class for myself.
No one is when they start.
Yeah, I know. Yeah, it was kind of like my dummy project to actually work with a single cell model and then build a class to plot myself. So I also have a class that I plot, and you can add functions into those. But basically, what you want to do is to go and look here into the data set. So the folder that you got, for example, for this simulation with the netpar. Don't mix that up with netparams. Netpar, it's a random name that I gave. And you're going to have the 2D, for example, the 2D net PNG, raster PNG, which I just showed, but you also have the JSON file. So here you have all the data points for your cell, so you can go ahead and access the data in there and then plot the surface plot or whichever plot, like a spike detector, something like this, yeah.
Okay. Can you change two parameters now?
Yes, I think I showed this one with the GNA and the GK.
Okay.
Bar, yeah. So, but yeah, I can just go ahead and show you the code up here. Yeah.
You'll be putting this code in the updating it, right?
Yes, I'm actually gonna share with you guys the one that I have in my GitHub, because that one I can like leave the parameters and everything with the answers there, so you can just look it through, and it's not gonna be once you move into the terminal, it's not gonna be that many steps like you have here. I'm gonna show in the end what it's actually batch sim NetPyNE and what's just Google Colab. But yeah, here when you want to run through two parameters, this is the last thing I want to say about it. You just declare them here, and what NetPyNE is gonna do is that it's gonna hold the first one and iterate over the second list of parameters. So if you had a third list, it would be holding this one, and then changing all of this here. And then holding this one, moving from this one to this one, and then changing this list once again. So yeah, they tend to grow as you increase more and more parameters into your batch simulation. And there's
they
another...
grow very quickly. One more parameter is, as many more simulations as the other parameters. So yeah, grid search is not a great way to explore a huge parameter space.
Yeah.
Excuse me. João, let me just ask, if I don't want to iterate over all, if I want to make pairs of parameters, just test this with this with this?
Yeah,
is it possible?
It's good to have a fantastic crowd because they just keep you progressing through it. Yes, so that's one thing that I added here is the group params. So I don't know why it didn't work in the collab, but this is exactly how you declare it in the batch. Usually you have like this outside of here, so it'll be...
João, you have an extra bracket? You only need the square bracket. So that one you can remove, and that should work.
On the tuple?
Yes, like that. Yeah.
Yeah. Let me see. Yeah. Maybe. Yeah. Let's try.
Excuse me. May I ask a question? Sorry, I interrupted someone.
Oh yeah, just go. I'm cleaning the front. Yeah.
We love questions.
Yeah. Okay. About those JSON files, you already cleaned the context, but nevertheless, the JSON files you mentioned, those which contain the results for each parameter combination, how to explore them? Should I use some general packages for JSON files, or could they be loaded with NetPyNE? I mean, when we simulated in non-batch regime, we had this sim object that we explored. Is there a way, for example, to convert this JSON file to sim object or any other object NetPyNE uses to use its functions? I mean,
do you mind if I jump in here real quick, João?
Yeah, I was gonna hand it to you because you're the one working on it.
Yeah, so I'm a developer. This is one of the projects I'm actively working on, sort of as we speak. And right now, as most projects that evolve from need, you don't really design them well. You know what I mean? You don't design them perfectly. And so most of our analyses and plotting are intertwined. You know what I mean? We needed to analyze something and plot it, and so we used our NetPyNE stuff to do it. But now we do want to separate plotting and analysis and plotting. And that is actively going on. And hopefully within a couple months, we'll have a new release of NetPyNE, which separates these nicely. At which point, the plotting is completely separate. So NetPyNE will generate the data format you need to feed in to any plot, but also anybody else can feed their data into that plot. That's something we very much want to do. So anybody can plot any data using these same routines we've developed, but it's a work in progress still.
Okay, so in a future release, plotting functions would be compatible with these JSON files, right?
In the future, they will accept external data, and you can plot external data with the NetPyNE analysis in the future.
Okay, thanks.
Yeah.
Sorry, Joe. Something you can do right now is you can load the JSON files. So there is a function in NetPyNE that is sim.load, and you can put the name of the JSON file, and then you can use the plotting functions. So you do sim.load blah blah.json, and then you can do sim.analysis plot raster.
So it is implemented.
But that's not external data, right?
No, but I mean, you were talking about JSON files generated by NetPyNE or not?
Yeah, by the batch simulation, the one.
So if the files are generated by NetPyNE and saved in JSON by NetPyNE, you can then load them using this function and plot using the NetPyNE function.
Okay. Thank you.
Yeah, any data we generate, we hope is useful inside our own code.
Yes. So I went on and just ran this simulation here with the group parameters. So we can see here, yeah, you can put them in this inside the brackets of the function, or you can externalize here as a different variable and then call this variable. So group params equal this variable, and here you just put the pairs of parameters that you're gonna add. I mistakenly added the brackets because sometimes when you have a parameter that's comes from a key from like another dictionary, you might want to have that set up as a tuple. So, for example, if I was looking for, let's say, change the declare like HHGNA bar. So you would put within parentheses HH, comma GNA bar, and then outside. So this is one parameter you're declaring, and then comma, and then the other one you want to pair it with. But here, because we already have those parameters declared explicitly, so GNA bar and GK bar, they are single parameters that we have in the, not this one, in the config cell params that we have.
And a quick note, just NetPyNE is a work in progress. And yeah, a lot of our functions require lists as inputs. And usually, maybe it might just be a single string in that list or a single whatever in that list. But unless you put in a list, it breaks. And we are working on robustness. So we want to, whatever you put in, if it has to be a list, let's put it in a list and throw it in. But again, help us develop NetPyNE. Come join us, report bugs, submit improvement suggestions on GitHub. You know what I mean? It's the only way we'll get a lot better.
Yeah, and yeah, we grouped those two parameters, and now you see when we ran, instead of having 0, 0, 0, 1, 0, 2, we just paired them. 0, 0, 1, 1, 2, 2. And we'll probably not have a pretty dynamics because, as we've seen in the previous simulations, we increase them accordingly to one another, so they will probably cancel out each other. But it's good to see that we can have those two parameters, because yeah, sometimes you want to change two things together at the same time. So yeah, we're not seeing any like behavior, but yeah, it's because those the ratios between the values, they're kind of the same.
Okay,
excuse me.
Oh, sorry.
Just to clarify, could you scroll up to the main function for a second, in which you set the parameter list? Yeah, for example,
yes.
For example, those. Mm-hmm. So to make combinations, you need this special mechanism, right? These grouped params. Mm-hmm. I mean, for example, when you write params GNA bar equals to this list, .12, .5.
So real quick, that must exist in your simconfig. You must have a simconfig .GNA bar in order for this to work. Okay. Yeah,
I understand it. The question is, in this list, only floats are accepted. For example, if an entry of this list, for example, 0.5, it should be always a number, or could it be any other object, for example, like string, list, or some other object, or not?
We're doing our best to make this robust, such that if you put something in that's wrong, if it's supposed to be a string and you put in a list, or it's supposed to be a list and you put in a string, we want it not to crash later in the program where it does now. We want to immediately tell you that you put in the wrong input, or fix it for you and give you a warning. But it's, you know, this is a work in progress. And,
I mean, and how's it now? Because if you could, instead of one value in each position of the list, for example, pass a pair of values, you could, for example, like a tuple of two values, you could modify your function that runs your config and unpack this pair Would it work or not for now, or only numbers are accepted? You're muted, Joe. Joe, I don't hear you. Sorry, you're muted.
Sorry about that. Salva is the one to ask about this.
Yes, so it would work, yes.
Okay.
It would. That's
Perfect.
cool. Thank you.
And values that are expecting a string or something, they should come through. Like if you have a synaptic mechanism that you're changing, so like excitatory, inhibitory, you can pass those strings into it.
And there are complicated ways to change things that are deep inside something. Yeah, if we need more complexity as your models develop, we'll help you get there.
Yeah, I think that's pretty much. Let me know if you guys like still have questions about changing those parameters. I have like other suggestions of things that we could change to look into it, but it seems like everybody got a hold of them pretty well.
João, can we explore at the same time different kinds of parameters like cell parameters and network parameters at the same time? Okay.
Yes, we can do this. So for example, let me show. It's because I don't have them. I didn't specify them here, but let me just. Sorry, yeah. If I go here and programs, net things, look for the net params. Okay, so in this one, I'm exporting a list, a set of network parameters that I'm changing. But I can also go here and then modify it to export something that's related into the to the cell morphology. At the same time, in this one, for example, I also have a targeted net steam that I have, which is a stimulation parameter that I'm passing to the cell. And that one also can export parameters. It might be a bit more, make a bit more sense if I show like how the code actually looks in the, yeah. How it actually looks when you're like programming that in VS Code, because in this one I actually went on and just put chunks of the things that I need to pass into the code, so it's more clean and easy to look into. But yeah, you can have everything there, export all of those parameters in the config file, and then at the end of the day, your config file is like a huge list of things that you're playing with when you're changing the model.
Okay, thanks.
No, you're welcome. Yeah, I think I have them here, like net params. Yeah, this one, if you look into it, there's a bunch of them that this is like all of the simulations all together. And then yeah, you have, for example, the add Iclam together with a pre-Iclam, so you have like 2 Iclams separate, add net steam, add targeted net steam, group net steam, which is like a bunch of them together. Yeah, and yeah, it depends on who's working with the code and what stuff you add to it. Anything else? All right. Yeah, I think that kind of does it on my side. Hope you guys enjoy the presentation. Yeah.
That's great. Thank you, Joao.
Very helpful. Thank you.
Thank you.
Thank you so much.
Thank you. Thank you.
So we don't have this on the schedule yet, but Monday morning, first thing, I'm thinking we would do a session on, I would show you my workflow in Mac or Linux, which are basically equivalents. Creating a virtual environment, cloning stuff, doing your work, pushing back. And then after that, I'll do one for Windows. So this weekend, I will load Boot Camp and go into Windows and try to do this stuff as well to help you poor Windows users do cool stuff. So yeah, expect a couple sessions Monday morning if you're interested in getting your own machine set up and how to work with it. And Salva?
Okay.
10 a.m. New York time.
10 a.m. New York time, Joe?
For what
That's the
time
plan?
Monday morning?
Yep.
Okay, thank you.
Yeah, let's go ahead and keep with the same course schedule. We'll start at 10 a.m. I think we've got a talk at noon or something, but we should be able to get Mac, Linux, and then Windows installations done before the first talk Monday morning, I hope.
We will add it to the schedule and we'll let you know if there's any change. Okay, thank you so much, Joe, and everyone here.
Great presentation, Joe.
Weekend.
Thank you, guys.
Thank you. Oh, also, Joe.
Bye-bye.
Any more questions?